champions, welcome to Gagan Online Academy, IIT Physics Waves. This is me, Mallanna from Kadapa. Every sound you hear, every light you see, every signal that connects this world travels as a wave. If you understand waves, you can understand sound and optics. So get ready to think deeper and vibrate. Hello champions, let us have a detailed discussion on wave. Wave is a disturbance. Wave is a disturbance that transfers energy. That transfers energy, but not matter. This is very important. So waves are disturbances. They transfer energy. They do not transfer matter. I will explain with this example. Here a boy is holding a rope. He is moving the rope up and down. He is moving the rope up and down with his hand. That means he disturbed the rope. So disturbance is created in the rope. That disturbance is traveling and reach the tree. So the disturbance traveled here. So in this way, waves are created. He is moving his hand up and down. The disturbance traveling along the horizontal way. The disturbance is moving along horizontally, along the rope horizontally. See here, the disturbance is moving along the x-axis, right? You say he is moving his hand along y-axis, up and down like this. The disturbance is moving horizontally. See, the wave is moving horizontally. Here, crests and troughs are formed. Crests and troughs are formed. See here, this is crest, this is trough. Okay, crest and trough. This is crest and this is trough. So crest and troughs are formed. This is example for transverse wave. Transverse wave. Next, wavelength. The horizontal distance between two consecutive crests or two consecutive troughs. Here one trough, here one trough. Distance between these two troughs is wavelength, or between two consecutive crests. Right here, two crests are there. So this horizontal distance is wavelength. So wavelength is distance between, distance means horizontal distance. Horizontal distance between two consecutive crests or troughs. Next, another important term is amplitude. This is represented by the letter A. The maximum distance of a point on the rope from its resting position is called amplitude. In this diagram, this is resting position when the rope is not moving up and down. Okay, from C, I am considering a point here, a point on this rope. So this distance, okay, this is called displacement or vertical displacement. If I consider this point, right, from this rest position, this is rest position, this is the height, vertical displacement or distance. Okay, so this point on the rope is having more distance. So this distance is called amplitude. So this is also amplitude from resting position. This is resting position. Okay, this point is resting point. So this distance is amplitude. Okay, So maximum distance of a point on the rope from resting position. This is resting position. So this is the height. Okay, maximum height of a point on the rope from resting position is called amplitude. Next, frequency. It is denoted by the letter F, small f. How many times you move your hand up and down, that is frequency, right? How many times you move your hand up and down. Okay, in our simple language, how many times you move your hand up and down, that is frequency. Or you say unit is cycle per second. Cycle means here one up and down is called cycle. One up and down, one up plus one down. Okay, that together is cycle, or we call it wave, or we call it oscillation, or we call it vibration. So here one crust and one trough, is called one cycle or one wave. Okay, so how many cycles are produced in a second, that is frequency. So in these diagrams here, we can find frequency. Here how many cycles are made, or how many up and downs are present. Okay, so here from here to here one wave. Okay, from A to B one wave, again from B to C another wave, from C to D one more wave. So here three waves are there, three repeated waves. Okay, three repeated waves. So here from here to here, A to B one wave, A to B one wave, and B to C one wave, and C to D one wave. How many waves are produced in second? Say in second the boy produced this wave. So here three waves are there. So its frequency of this wave is 3. Frequency of this wave is 3. We write H, meaning in 1 second he produced 3 waves. He produced 3 waves or 3 cycles, or he moves his hand up and down 3 times. That is the meaning. Okay, 3 waves. If you shake the rope faster, frequency is very more. Okay, if you shake the rope slowly, the frequency is very smaller. Okay, smaller the frequency. I will write here. If you shake the rope faster, okay, in this case frequency increases, wavelength decreases down. Okay, I will explain through this example, through this diagram. If you shake the rope, if you move the rope up and down very fast, then we have this kind of diagram. See, in 1 second we have many waves. See here, many waves. Okay, if you, that means wavelength I explained just now. Distance between two consecutive threads are tough. Okay, this distance is reduced, lambda is reduced. Okay, wavelength is reduced, frequency is more. See here, more waves are created. See here, more waves are created. If we move the rope slower, then what happens? See, that wave will be like this. Okay, in the same time, now see, we have wavelength is increased. If we shake slowly, if you shake the rope slowly, wavelength, frequency decreases, wavelength increases. Here wavelength increase, number of waves are reduced. Earlier case more waves are formed, now lesser number of waves are formed. Okay, that means frequency and wavelength are inversely proportional to each other. But wave speed is same. Wave speed is same. So V is equal to F lambda. This is formula for speed of wave. Speed of wave. That means how fast a wave travels. How fast a wave travels is called wave speed. Wave speed. It is denoted by letter V. Hello champions. Another important term is time period. It is denoted by the letter T. Here one example I am taking. How much time is taken by an object to complete a wave? Okay, time taken for an object to make a complete wave. Time period. Time taken to make a complete wave is called time period. Time taken to complete a wave. See here, this is one complete wave. So from this point, one wave is moving like this. So the time taken to produce this wave is called time period. Next, frequency. This time period is written as time period is equal to time by waves, number of waves. Now frequency. In 1 second, how many waves are generated? In 1 second, how many waves are generated? How many waves are generated? Or from this point, right, how many waves are crossed this point? How many waves crossed this point in 1 second is called frequency. I will make it clear with one example. Now frequency formula is, here we write number of cycles by time. Cycles by time. See, if you observe here, time period and frequency, time by waves, here waves are cycles, both give same meaning. Here cycles are waves. Okay. Time by waves. Here waves by time. That means these two are reciprocal with each other. T is inversely proportional to F, or F is inversely proportional to 1 by T. With one small problem, I will make it clear. Suppose time period is 2 seconds. Time period is 0.2 second. Time period is 0.2 second. That means to produce one wave, it takes 0.2 seconds. From this, I want to find frequency. So we know formula frequency is 1 by T. 1 by T. So 1 by T is 0.2. Again, by multiplying both numerator and denominator by 10, 10 1 is 10, here 20, 2. So 2 ones, 2 5s. So I got 5. So frequency is 5. Means 5 waves are produced in 1 second. 5 waves. 1 wave, 2 waves, 3, 4, and 5. So 5 waves are produced in 1 second. 1 second. This is frequency. So if you know frequency, you can find time period. If you know time period, you can find frequency. Both are inversely proportional to each other. Hello champions. Now we will discuss angular frequency. Angular frequency. It is denoted by the letter omega. Okay, omega. We know frequency. Frequency is 1 by time period. 1 by time period. Number of cycles made in 1 second, right? How many cycles are made in 1 second? That is frequency. If I say frequency frequency of a wave is 1 Hz. 1 Hz means frequency 1, meaning 1 cycle per second. In 1 second, 1 cycle is produced. In 1 second, 1 wave is produced, or 1 second, 1 oscillation is made. That is the meaning of frequency. Now, 1 cycle means here, this is 1 cycle, 1 crest and 1 trough. This is crest and this is trough. This crest and this trough gives 1 wave. We call it 1 wave or 1 cycle, okay, or 1 oscillation. Now we are expressing this frequency using radians in angular frequency, right? To understand this, I am drawing this the wave simple diagram. This is wave. Okay. Here see, from this point A to this point B is 1 complete wave. Okay, 1 complete wave. This line is called equilibrium position or mean position. Okay. So this is half wave, this is half wave. This half wave is looking like a semicircle. So how many degrees are there in a semicircle? 180 degrees. Here also one inverted semicircle, right? It is also 180 degrees. Totally how many degrees are there in one complete cycle? 360 degrees. So 1 Hertz means frequency 1 means 360 degrees, right? In circle, one complete circle, say 1 complete circle is 360 degrees. 360 degrees, if we express in radians, we write 2 pi radians. 2 pi radians. So now I am writing angular frequency 2 pi into, for 1 frequency, 1 wave, I am writing like this. Suppose if frequency is 2 Hz, frequency is 2 Hz, in that case I write 2 pi into how many? 2 frequency. Here we write 2. That means 2 frequency. Frequency 2 means 2 waves are produced. This is 1 wave. Okay, again 1 more wave. 2 waves are produced. I will change the color. Suppose if frequency is 2 Hz, right? Here 2 waves are here. 2 waves. In 1 second, 2 waves are produced. So this is first wave, black color first wave, and in pink color, this is another wave. So 2 waves are produced. 1 wave is equal to 2 pi radians. So 2 waves is equal to how many 2 pis? 2 pis. So we can write omega is equal to 2 pi into this 2 is what? 2 waves. So number of waves in 1 second. So that is frequency. So formula for omega angular frequency is 2 pi f. Okay, that means 1 wave. 1 wave means 1 complete rotation. 2 waves means 2 rotations. That means after 1 wave, another wave repeats itself. So to represent this frequency in radians, we use angular frequency. Omega is 2 pi f. If you know omega, you can find frequency. If you know frequency, you can find omega. If we know frequency, we can find angular frequency. Suppose frequency is 4 Hz. Now I am finding angular frequency. Formula is 2 pi f. So we write 2 pi. In the place of frequency, f is 4. 4 Hz this one, 4 Hz. So that number, only 4 we write here. So that is 2 4 ja 8 pi. So omega is angular frequency is 8 pi. That means 4 circles. How many circles are made? 4 circles, meaning 4 waves are produced. Okay, or 4 oscillations are made. Or 4 vibrations are made. Suppose if you are given omega means angular frequency, from this you can find frequency. So again we write formula omega is 2 pi f. Now I am writing 8 pi here. 8 pi, I can write 2 pi into 4. 2 pi into 4. Okay. Now this 2 pi is equal to 2 pi. In the place of f we got 4. This will give us frequency. Frequency is 4. Means 4 oscillations are made.